So we're looking at a Sega Saturn, and when released back in 1994, this was arguably the king of gaming consoles. 2 CPUs, video acceleration, nothing could touch it. And because it was made by Sega, it also licensed a whole load of arcade titles using very similar technology, and they looked amazing. Now the games came on CDs, which were amazing for the day, but now we have a little bit of a problem because these drives are now 20 years old, and while the machines will often keep working, the drives are dying left, right and centre. So we got to do something about this. Fast forward 20 years and we're living a bit of a retro revolution at the moment. And this is thanks to technology like this. This is a flash cartridge, and basically you can program this with any ROM you want. The spin-off of this is that there's an incredible homebrew scene that's now popped up. And while the brains behind technology like this come from all around the world, I want to introduce you to Dr. Abrasive, because for the Sega Saturn, he's conjured up one of the most insane flash projects I have ever seen.
Welcome to my mad scientist lab, or to my very messy desk. So this is a project I started, I think, around 2013. Basically, I heard about the chiptune capabilities of the Sega Saturn with its crazy multi-channel sound chip, and I thought, gee, it'd be nice to have one of those around. So I happened to be in Japan and wandered to a Super Potato and bought myself a Sega Saturn and managed to jam it into my suitcase and lug it home. And then when I got it home, I went, okay, now I want to write some software for this thing. What do I do? And I found out that there was still pretty much the original 90s technology for this device. So you had to go and get a mod chip, which people don't make anymore, funnily enough. You had to install the mod chip, and then you could burn CDs. I was like, could probably do better. So I spent a little while researching to see if there was some way to work around the copy protection. Unfortunately, the outcome of my research was that no, it actually works quite well. It detects a little wobble in the outer ring of the CD when it's trying to read the protection data, and that's not something you can do with a CD burner. When you buy a CDR, it's already got a spiral pressed in it, so no wobble for us. So I basically started doing some digging about the hardware architecture of the Saturn, and I was a little bit surprised actually to find out just how over-engineered it is. So it has I don't even know how many different CPUs. It's got 2 main CPUs, it's got a CPU just for sound, and in addition it has a CPU that just controls the CD subsystem. It turns out there's a whole operating system running inside this chip that no one ever has been able to access. So you can send it commands, it'll send you data, but no one knows how it works. There have been a couple of efforts over the years to decap the chip, so to open up the package and read out the ROM using a microscope. Unfortunately, it turns out it uses a technology called implant ROM, where you can't actually see it under the microscope. You have to do this complicated staining process. And so no one had ever dumped it that way successfully. So I sort of came along at this point and stared at it a bit and scratched my head and found all the different schematics for the Saturn you can find on the internet and sort of puzzled about how it worked. And eventually I came up with a couple of schemes I thought I'd try. So I went and got my hands on one of the CD drive CPUs, the CD block CPU. From a very friendly chap in Hungary who I don't think realised quite what I was going to do with it. He sent me the CD module from a Saturn, and I unsoldered the CPU from it. I made myself a circuit board and soldered it on the other board and basically tricked it into reading out all of its ROM content to me. And then in a very, very lengthy reverse engineering process, I basically went through and puzzled out how its internal operating system worked. So it's got 64 kilobytes of ROM and it's packed. It's completely packed with instructions. There's a lot of stuff going on there. And there's a lot of spaghetti code. There's a lot of weird, sort of obviously hacky bits of code. There's bits that have been written by hand and edited several times. I've actually been really surprised by how much you can see of its development history just by kind of looking at the code, which is really cool. So I sort of, as I started to find my way through there, and building up a map of where everything was, then of course I gravitated towards the protection area and finding, you know, how could we possibly run CDs on here. The first thing I was looking for, which I was really hoping to find, was that they'd put in some kind of a back door which would let you basically open up the system in some way with a burnt CD.
With a dev kit kind of sort of feel to it.
Exactly. And I know there are discs that they made for use by developers which would put it into a mode where it would accept burnt discs, so it would temporarily disable the copy protection. But those discs still had that wobble burned on the outside, which is how they ran in the first place. So I was hoping that there'd be some more secret mechanism that would do the same thing. And unfortunately I didn't find one, but this had sort of piqued my interest by this point. I'd gone pretty far in, so I figured I'd better find a way out. So continuing my little reverse engineering journey, my attention next turned to the video CD port on the back of the Saturn. So that was an interface they provided to support playing video CDs, which at the time still looked like they would be a thing, especially in Japan. So there's an add-on card which you could buy, which plugs in the back of the Saturn, and it contains an MPEG video decoder chip, an MPEG audio decoder chip, a bunch of RAM, a bunch of ROM, and basically so that would augment the functionality through the CD block CPU. And when I dug far enough on this, I found that there was actually, in the ROM, most of it contained a program for the Saturn to run. Just like a CD, it would boot up, show a menu, do user interface kind of things. But there was also a little thing of random looking code that was kind of hidden. Not very well hidden, of course. You can't really hide a piece of random looking code on the front of a ROM, but it was not obvious from the normal interfaces. And as I was looking on the inside of the CD block code, I realized that this was actually encrypted. It was an encrypted chunk of data. I go, why is this encrypted? This must be important and possibly interesting. And as I continued to dig, I found that it was actually a piece of code that would be loaded into the CD block CPU. So the CD block is like this walled little fortress. You can send in commands, you can get CD data, but because it manages the copy protection, it doesn't let you run code on there. It tries to keep itself completely sealed off. So finding that there might be a way to run code on there meant maybe I could find a way around the copy protection. Maybe I could make a mod chip that would plug in this slot. So instead of having to pull your whole console apart and put in this kind of really a bit janky piece of circuitry that taps into the CD drive cable, maybe I could just make a neat thing where you pop open the port on the back, shove a thing in, and off you go, which would be great. And then as I did some further digging, I found there are some reasons that might be a little bit difficult, and I did more digging and more digging and more digging. And eventually I somehow came to the conclusion that what I should really do at this point is ditch the CD drive altogether and essentially insert tentacles through the video CD slot straight into the CDB brain of the system. So at that point I embarked on developing a card that would plug into this slot, so no soldering, no taking out screws, no anything, that would have, at the time I envisioned it with an SD card. This thing would have an SD card, you plug it in, and it would basically replace the CD drive. So instead of putting a CD in, you'd put an SD card with an ISO on it, for example. And essentially that's what I've ended up doing. Over the time, the design has changed a little bit. I realized it would make a lot more sense to support USB, because of course you can get much bigger USB drives if you want to support storing more than one image on there. And essentially it's something I've worked on and off in my spare time over several years. It's been my longest running project by far. This is now at the point where not only can it boot and run games, I've finished just recently, in fact, putting in audio support so it can play audio tracks, which many games of course use for background music in that era. And I also took the opportunity to add some features that I thought would be nice to have that you can have with this technology. So I, for the time being, possess the only Saturn in the world that's capable of writing files to a USB stick. So there's actually, for developers of Homebrew and anyone else who might want to be enthusiastic about this, there's the ability to actually read and write files directly on the USB stick that's attached to the device. So managing your save games, and I'm hoping to go back to the original plan, back to chip music, and in that case you'll be able to load samples, store your songs on your USB, because where else are you going to do it?
Exactly. So a question to do with the CD-ROM reading and the way the sectors are set up on the disk. let's just say your drive had packed it up, like it died in your Sega Saturn, which is happening with a lot of them.
Absolutely.
Could you take your games, for instance, put them in your PC, rip them, and then use this player to play them?
Yeah, you absolutely can. Unlike some other consoles, the Saturn discs are not protected from reading at all. You can read the entire thing, no problems. I know there are a lot of machines like mine, for example, where the CD drive is actually dying of old age. I mean, I have to admit, I never imagined that solid-state lasers would die of old age. I thought they were pretty bulletproof. But it seems to be an incredibly common problem, and it's actually something I wrestled with when I was starting to do my research on how the drive protection worked, because it wouldn't read the real discs half the time, which was infuriating. And those mechanisms are getting harder to find and harder to replace, of course, as they get older and older. And of course, all the replacements, if you get them secondhand, can have the same problem. So really, there's two things I want to achieve. One is the sort of archival side of things. I would like people to be able to trust that these systems are going to keep running, with fully replaceable solid-state systems, of course. Now, hopefully that can happen forever. And the other aspect is that I would like to enable people who would, for example, like to exploit more of the power of these systems. I think previously with homebrew being predominantly through burning CDs, it's a bit of a high threshold for people to get into, and mod chips are hard to find. If you make these things more accessible, you open up that console to more people. And the architecture, I think, can be quite powerful if you can handle it correctly. And I'd be really excited if this can open up more possibilities for people, either musically or wider demo programming or who knows what else.
Absolutely. And for the music aficionados out there, we're talking, this is from memory, 32 operators of FM that can be chained in any way you want and terminated and pulled out of the chain at any point.
So I have to say, it has been about a year since I myself looked at the documents of the SCSP.
So this is my job, is it? Yeah.
So from memory, it does have 32 channels. You can load arbitrary samples and chain them in arbitrary ways to modulate each other. There's a super complicated way of doing inserts and mixing and turning. There's a lot of configuration registers. And it also includes a programmable DSP, which you can mix into different channels. So that means if you wanted to get really crazy, you could actually program your own DSP effects, which I haven't seen anyone doing, and I'd love to.
Wow. So could you do delay lines and things? Do you have like DMAs and stuff?
You've got a little bit of memory there. Yeah. And there are DMA facilities as well. So there's a 68K that exists just to service the sound chip.
Oh, that's a lot.
So there's a lot of beef there. There's a number of other features that aren't very obvious about it. So the SCSP has native MIDI, for example. So if you have the right adapter, you can connect to the communication port at the back of the console and then to MIDI at the other end. And that's basically, there's no electronics in the store. It wires it straight through. There might be an opto-isolator, but there's nothing to it. You can build those at any time. So it's got a native MIDI interface. It actually has digital I/O interfaces as well. So there's essentially I2S buses that run up to the cartridge port at the back of the console. So you could build a cartridge that has, for example, SPDIF in and out, and then hook them up to an audio workstation if you want to do your sample prep that way, for example.
Wow, and that'll get you a super clean audio output as well.
Absolutely.
Wow, because is the audio internally filtered?
It is a bit rubbish, I think.
Yeah.
Like it's a bit noisy, and the design is, it's not winning any prizes, I think, but it's quite straightforward.
Great. Well, this is exciting. Let's have a look at it.
So this is my development system. So this is a regular old Japanese Sega Saturn, but I've basically taken out all the parts that either I don't need or that pose a threat to me. So over here, the power supply has disappeared because 240 or 110 volts hanging around when you're poking at 5 volt systems is a recipe for sticking your elbow in pain. I don't recommend that. The CD drive has disappeared as well, so that normally sits bang in the middle of everything, like so, on a big metal plate, which you will also see is missing. So, funnily enough, I don't need the CD drive since I'm developing a replacement, so that gets to go out of the way and out of the picture. Within the console itself, I think the most exciting thing, everyone will agree, is this board over here in the corner. So this corner is where the video CD card would normally slot into a console. So in most consoles, this slot is permanently empty. In this case, it has my prototype board. You can tell it's a prototype because it's incredibly ugly and has all sorts of crap hanging off it. Feeding out the back is the USB port. There's a debug port for the CPU, so that's how it's programmed and controlled when it's running. And there's also a programming port for the CPLD, so there's a programmable logic device on the back side of the board. So if you want to take a quick look at the other side of the board, there's not much to the electronics, not compared to the original board that was in there anyway. So down here we have a CPLD, so that basically lets me implement a bunch of digital glue logic to connect the bus that used to hold the MPEG material to my own microcontroller over here. So this is an ARM microcontroller. It's actually reasonably powerful. It runs at 72 megahertz, which does make it the fastest piece of gear in this particular machine. But it has the properties not only that it's conveniently small, but it has enough power to do all the heavy lifting to convince the Saturn that there is in fact CD data streaming in from this USB port conveniently located over here. Apart from a voltage regulator over in this corner, there's nothing else to it.
There's a little bit of input protection, or I/O protection is there as well? Or?
There is no I/O protection. There is, oh well, that's not true. So these resistors here are just series termination for some of the high-speed lines. Essentially, they were put in as design insurance. So this is the first revision of the board. This is the one where I came up with the idea and thought, I know, I'll build it like this. And then you can see from the presence of these little coloured wires on the surface that in fact the way I thought it worked is not always the way it actually worked. Luckily, you know, after a bit of experience with these things, you get quite good at patching up your mistakes. And of course, somewhere down the track, I will actually make a new revision of this circuit board and erase all evidence that I ever made any mistakes of any kind at any time.
Affectionately known as bodge wires.
Exactly. So there's a good collection on this board, but...
There's not many. I've seen a much worse layout than that. That's actually really quite nice layout. Did you have any problems with timing and the way you had to change like lengths of your bus or anything like that? Or is this low enough clock speed that it doesn't matter?
I had a couple of termination issues early on, so I seem to recall it's probably why this little bodge resistor is there, and I think, oh, that's a bodge cap actually, and there's a bodge cap somewhere on this side as well. Here we go.
Yeah.
But apart from the termination issues, there's there haven't been any signal integrity issues whatsoever, which has been lovely.
Wow. So when you fire it up, take us through it.
Alrighty. So the way this is set up at the moment, it takes over the console at the point where it boots into the CD player. So as it's partway through booting into the CD player, it takes over, fades it out, and then brings you to a menu. The menu exposes basically all the files on the USB drive. So in this case, this is just my testing drive. There's really not a lot on here at the moment. The most important thing to do is hit the green button, which will load whatever you're pointing at into the virtual drive and start the boot sequence.
Rockin'. How many times have you heard this song?
More than I would like to.
I bet. Amazing.
Painfully catchy.
But geez, it works straight away. Like it's about the same load time and everything. It's real time, I assume.
Absolutely. It follows the timing of the original quite faithfully.
Yeah, that's brilliant.
So I have had a feature request to essentially put it into kind of a turbo speed mode and just throw data at it as fast as it can handle. Which is an interesting idea for homebrew software or for testing or for that kind of thing. But I'm also quite wary of what might happen with that sort of thing. The operating system inside the CD block actually runs several different tasks simultaneously, and it's obviously been quite carefully tuned so that they can all run and keep everything going on at the same time with quite limited resources. So if you were to try and run it faster, you increase the risk that everything's going to collapse and it's just going to stop.
It's the thing with these old systems, because they were never designed to be faster or slower or overclocked or have different components put in them. So the components were very much on edge. They would all just time exactly, and one thing would feed something, you know, just as another expected it, and something. So all the processes were very matched, as far as I understand.
Absolutely. So that's something that's proving an obstacle to emulation. So one thing I've been doing with this is that all of the reverse engineering I've done and understanding how it works and pulling it apart, I've shared that with emulation authors, and I've actually been working with a couple to try and help them implement emulating this CD block using the dumped ROM inside their emulator. So this has been difficult for emulator authors in the past because without being able to see the original code, they can't specify how it works. They basically have to try and work out what it's supposed to do based on the publicly available documentation, which is almost nothing. They've done a great job based on what they have. But by actually being able to look under the hood and see how the thing works in the first place, that means they'll actually be able to get cycle accurate emulation. One of the biggest challenges there is actually because it's so timing sensitive. It's trying to stream, data coming off a CD. There's no buffer in between. It has to pick the data up as it comes, and then also get that to the rest of the system. So this is exposing areas where the emulators have never had to deal with this particular piece of detail before, and that's actually quite challenging. There's some sort of fundamental re-architecture that has to go on here for it to support those particular things accurately.
And is some of that to do with oversampling, the way it does its instructions and things, so it can do stuff at a sort of sub-instruction level and have timings and things? Or
it's similar to that, but kind of the other way. So
right.
Emulators, for the sake of efficiency, even when there are two CPUs in hardware that would normally run off the same clock, instead of running them both one for one, they'll actually run them in blocks. So they'll run this CPU for 100 instruction, this CPU for 100 instruction, this CPU for 50, and all the different parts of the system run sort of in sync, but slightly, they're not actually being run at the same time.
So you can have pause states as long as the output you're getting at the end of a set of instructions is the right.
That's the idea.
Yeah.
So that's one of the big sort of challenges and approximations in emulating multi-threaded systems like this. So there's all these things that are happening in parallel, and you could emulate each one cycle by cycle, destroy your time efficiency because your CPU cache won't hold everything. So it's a compromise, and it does diminish accuracy. And it's really about choosing how you make those compromises. So to try and implement this particular bit of emulation, it means going back and changing some of the compromises that were made previously.
What's this going to do for the Sega Saturn scene that's out there?
So there's a few things. One of the things in the most immediate term is that the information I've gleaned from the reverse engineering efforts is actually now feeding into emulation. So it will improve the fidelity of basically all the CD operations, which have been a black box until now. So that's a nice thing. That's already happening. In the longer term, I want to turn this into a piece of hardware that people will be able to get their hands on. So one of the problems with mod chips at the moment is people don't make them anymore. So I think there are some open source mod chip plans now, but still, it's quite a high barrier to entry.
And if you bought a Sega Saturn and you don't have a soldering iron and things like that, I mean, it's a big thing to add a mod chip and risk your hardware.
Absolutely. So the mod chip is a barrier to homebrew, and a barrier to using it at all is the fact that these consoles, the CD drives, are slowly dying. And, it was, especially in the West, it was never that popular a console in that generation. And so finding spare parts is actually a little bit difficult. So ultimately, I'd like to help not only homebrew become more accessible and also more powerful with a USB interface, but I'd like to see it with a place in archiving. I think it would be really nice to know that essentially everything will remain accessible even when your CD drive, completely gives it up, that you'll still be able to use your console, all of its features as it was intended.
And what's been the most awesome thing you've discovered about Sega Saturn and maybe the scene and everything around it so far?
I don't know, actually. That's a really good question. I'm certainly pleased to find that the scene is, full of people who are really interested and excited and just passionate about what they do. Some of these passions are very specific. Some people go and, collect every ROM dump chip they can find, and, it's a kind of similar role to being a librarian, I guess. You just have that passion for information and for collecting it and, manicuring it, getting good information together, which is really fascinating to see. I think it's really, really lovely that people do these things in their spare time. I couldn't have done this project without standing on the backs of others. So one of the biggest things when I dumped this ROM, so I couldn't have dumped the ROM without schematics that people had published. So there are reverse engineered schematics, there are leaked schematics, but there's just these little fragments of information that people have brought together. And that was the gateway into dumping the ROM in the first place. Then when I dumped the ROM, I had this huge blob of binary that was all this code, and I didn't know where anything was. And just to be able to find my way in and map my way around, I had this map of what all the different CD block commands were that you could ask it to do. And that was documented by emulator authors and published in a wiki. So one of the big emulators, Yabause, I actually don't know how you pronounce it, but there you go. On their wiki publish all the different CD commands that they know of and what they think they do, and that basically was the first thing I looked for when I got this ROM. I went, okay, somewhere in here is a big table that dispatches all of these commands. And it was like a Rosetta Stone. You go, these commands affect this stuff. And oh look, the code they run is all over here. This other group of commands does these other things. And so it showed me around the ROM and showed me where everything was. So without that, it would have been 10 times, 100 times harder. I don't think I would have gotten there.
Eventually, would you love to release some kind of just card that people can purchase?
Yeah, so I think at this point, this has been on hiatus for a while. I was finishing my PhD, getting some stuff sorted, and now I've basically decided it's crunch time. I really want to get this to the point where people can actually have it in their hands, they can plug it in, they can use it. So really now it's just a question of what form that's going to take, what features it's going to have. So I want to keep it simple. And it will be firmware upgradable. There will be the opportunity to add some more stuff to it later, but I want something that's simple and reliable. That's how I like my things to work. I'm just going to assume everyone feels the same. Less features, more good. Still to decide is how it's going to look. So maybe it will just be a bare card and you have to figure out how to put it in there and keep it in there. Also to decide, maybe some accessory kits would be neat. One thing I personally would quite like to do is to build a kit where you can take a 2.5-inch hard drive and actually build it inside the console. So take out the CD drive, put in your hard drive, and just have it as a complete replacement. So, with a few little bits of wire and a little bit of soldering, that will definitely be possible. It's just a question of how people can access that.